Savannah, we looked last day an awful lot at a mass hanging from a rope, because I can do an awful lot with that. In fact, almost certainly there's going to be a question like this on your test. So here is the next question. It says, suppose the cord tension is measured at 98 newtons. What's the acceleration of this mass? You know what it's a good job for? A free body diagram. So I'm going to represent the mass with a dot. What are the forces acting on this mass? Get the obvious one. This is what I said last day all the time. So gravity down. And we said last day that gravity ended up being as an equation, mg. That's ma in disguise. But we said that if we're talking gravity, how about instead of a, since we know it's 9.8, let's put a letter g there to remind ourselves to use the 9.8. What else? Now, if this was all there was, this is the free body diagram from object in free fall. Look at the picture. Is this object in free fall? Or there's a rope. You say, oh, what did we call the force from a rope or a cable or a string? Tension, what you were feeling when you didn't know the correct answer for a second there. Bigger, smaller, or the same size as mg? That's why this is a tough question. I don't know. Because for me to figure out whether it was bigger, smaller, or the same size as mg, I would need to know which way this is accelerating. Did the question tell me which way this mass is accelerating? You're going to need a calculator. Kenzie just had that light bulb moment. I saw her reach for it just before I said that. I saw her go, I think I need a calculator. Yeah. And here's why. Can you very quickly calculate mg? Okay, I lied to you. Are you too lazy to get a calculator sometimes? What's g really close to? 10. mg is roughly 12 times 10. In your head, what's 12 times 10? So mg is going to be a little less than 120. What's tension in newtons according to this question? What do I know mg is? Around 120. What's tension? 120, 98. Which one's bigger, mg or tension? So I'm going to draw tension shorter. You could have gone 12 times 9.8 and gotten it exactly, Kenley, but if you're asking me, do I often just multiply by 10 if I want to do a best guess quick? Yeah. So do you see how I figured that out? This time, now that I've drawn that, look at the free body diagram, look at the free body diagram. Which way must that be accelerating? Gotta be. Who's winning? Here's my equation. So just to jog our memory, let's go winner minus loser equals ma. That's what we said we're always going to do. But now specifically, which force is winning? Gravity minus which force is losing? Equals ma. Antonio, what did this question want me to find? The one that we're on right now, this one. Yes. No, I figured, you know what? Do me a favor. 3 questions ago, what were they asking me to find? Just for giggles. Let's just, no. Yeah. Come on, Antonio. Here we go. What does this question want me to find? Huh?
Acceleration.
Say it again. You're right. Say it again. You're right. How to get the a by itself?
Divided by n.
Oh, you mean I don't have to memorize a whole bunch of different equations? Oh, well, that's cool. In fact, ready? Mr. Dueck being a bit lazy. How am I going to get the a by itself? The whole thing that you said. Okay. Boom. Boom. Is that what you said? And it would be divide the whole thing by m. There's going to be a big fraction. Yes? So here we go. A equals, what is m? How big? 12. How do you know? Kilograms. Right? We're adding to our, this is why I said it's worth memorizing what units go with what so that it becomes kind of plug and chuggish. G, 9.8. Why not negative? We took care of the negative with our winner minus loser shtick. We don't need to put the negative. We're just putting magnitudes into this equation. Minus, what's tension? Good, the question told me. All over 12. Is this a fraction? Is there more than one thing on the top? Brackets around the top. I would strongly encourage all of you to practice typing this into your calculator. Courtney, can I be Mr. Dueck being mean? Can you put your phone face down? Because you're just not that important. Thank you. I know you weren't looking at it. I just didn't want it to become a distraction. 12 times 9.8 minus 98 divided by 12. This is accelerating at, did you get 1.6333? 1.63 units. Logan, it's an acceleration. Come on, I went to you with this one on Friday. It's an acceleration, or a Monday. What are the units for acceleration? Yes, thank you. If they had asked for a direction, down. How do I know? Newton's first. Okay. They just said, what's the acceleration? I'm assuming they want the magnitude, but if they had said magnitude and direction, I could come up with that. Free body diagram, you have no idea how powerful a tool that is. Mr. Dueck jumps out of an airplane. Eventually, I jumped out of an airplane. Once he pulls his parachute, air drag has a force of 745 newtons. What's his net acceleration? Antonio, what does this question want me to find? What did the last question want me to find? Okay, just for giggles. You know what this is a job for? A free body diagram. Now, how did I know that? Did they mention a force in this question, Antonio? Read the question.
Yeah.
How do you know? Okay, newtons, and they said air drag has a force of, but even if I just said air drag is 745 newtons, so you know there's a force. And if I'm in free fall, do you know that there's another force acting on me? What? That's a job for a free body diagram. If you have more than one force, you're probably pulling off a free body diagram. So let's represent Mr. Dueck with a dot. What are the forces acting on Mr. Dueck? Get the obvious one. What else? Air drag. Which way? Up? Bigger, smaller, or the same size as mg? I don't know. Oh, it's going to be 92 times 10, roughly. 920. Air drag is that. So air drag is mg is 92 times 10. Mg is roughly 920. Air drag is, yeah, right now I'm at the stage where I'm still accelerating down. Now, in real life, this is why I've told you air resistance is such a tough force. In real life, air drag is getting bigger and bigger and bigger until eventually air drag and mg are identical. Then my forces are balanced. I stop accelerating. I'm not stopped. I'm going at terminal velocity, and if I hit the ground at that speed, I'm not walking away from that, but I'm no longer speeding up. Who's winning? Sorry, pause. Antonio, what did this question want me to find? So I think we're going to go winner minus loser equals M. A, who's winning? Who's losing? What's that equal? MA. Now, the nice thing about this template is in a few days, we'll just be adding more and more forces. Oh, this question has 8 different forces on it. No problem. We can deal with it. Which ones are winning? They'll be pluses. Which ones are losing? They'll be minuses. Equals MA. Mr. Dueck? Yes, Courtney. What are they asking me to find? Courtney, what are they asking me to find?
Acceleration.
Mr. Dueck, yes, Courtney. If I'd really been paying attention, would you have been okay if I went winner minus loser equals in one line? You know what? I'm okay if you notice, dude, I'm trying to get the A by itself. I'm going to divide by M. And if you do that on the first line, Jagger, without rewriting it and crossing it out like we did up here, I'm fine with that. You okay? That's what you get for showing up late. 92 times 9.8 minus 745 divided by 92. In a vacuum, in Freefall, the acceleration is 9.8. But now we have enough physics scale that we can start to say, okay, if we bring in air resistance, if you tell me how big air resistance, now I can tell you what your actual net acceleration is. Not the 9.8 in a vacuum, but what is it actually here? What'd you get? Oh, by the way, there is a built-in error check. What's the maximum the acceleration could be? No, what's the maximum the acceleration could possibly be in a vacuum? Just magnitude. 9.8. I built an error check. I can't get an answer bigger than 9.8. If I get an answer bigger than 9.8, I've clearly made a calculator error. Yes? So there's kind of an error check there. Sorry, what did you get? 1.70. Anybody else? 1.70? Units, it's an acceleration, Logan. Good. You got your punchline now? You're with me? Yeah. Okay. Let's go cliff jumping. And we looked at this a little bit before Christmas. In fact, I think we looked at the world record cliff jump. We saw the video of the guy who clearly didn't hit the water quite cleanly enough. Caleb jumps from a 19.5 meter high cliff into a lake. Suppose his mass is 65 kilograms. A, find how long it takes until he hits the water if we ignore air drag. Okay. What's this question asking me to find? All of the stuff from before Christmas is still fair game. I'm not going to suddenly say, oh, you don't need to know that. That, for time, that's where we use that DFIC approach. So I'm going to go T equals question mark, and I kind of feel better. What else do I know? What's the distance? It's not 19.5.
Negative.
Because we're starting at the top and we're ending up below from where we started. Here we did have to be fussier with our positives and negatives. What else do I know? What's the acceleration?
-9.
And here we did include the negative because we've let down be negative. Somebody said mass. I don't think we used mass before Christmas to find stuff. By the way, if they need me to find a force, I'm guessing that's going to be coming later on in this question. Just a guess. What? Oh, because when you cliff jump, what's your VI if you just step off? Yeah. I'm looking for an equation that has those in it. Oh, did you hear what Jabber said? He said D equals AT squared over 2. He didn't even bother reading the VIT. I'm fine with, because VI is 0. What are we trying to find?
So it's going to be square root,
divide the A times the 2. Now, again, some of you like to write it as 0.5 AT squared, and I'll show you that version. I hate having a decimal inside of a fraction. So what did you say? You said it's going to be the square root of...
2b over 8.
Yes. Or if you did it this way, it's going to be the square root of D over 0.5A, because dividing by 0.5 is the same as timesing by 2. Okay? Whichever way you wrote it, I'm fine, but I'm erasing the decimal inside of a fraction because that's blah. So it's going to be 2 times negative 19.5 divided by negative 9.8, square root of that. Oh, Mr. Dueck, this is like familiar territory. Yeah. Almost bang on 2 seconds. I'll go 1.99. But if we were counting it, if you were watching your friend and you were going 1,000, 2,000, probably you'd say, wow, it's pretty much 2 seconds, right? Okay. Find the velocity as he hits the water. What's this asking me to find? VF. I'm not going to relist everything because I have it all listed there. I'm going to be lazy. I'm going to use VF equals VI plus AT. I could also use VF squared equals VI squared plus 2AD, but I'm going to pretend, Sam, that now we've done enough physics that I can use an answer to find an answer and be confident that that first answer was right and that I'm getting the second answer right, especially if it's lazier. So I'm going to get this negative 9.8 times, I'm going to write 1.99, but what button am I going to use on my calculator? Yeah, more accurate and less typing. And I get negative 19.5. This is just an interesting fluke. The distance that you fall is negative 19.5, and the velocity that you hit is negative 19.5. Don't think that they're the same number, or don't think, oh, your final velocity will always be the same as your displacement. That's just a fluke with the numbers that I made up. Okay? Meters per second. If Caleb's feet just barely touch the bottom of the lake, which has a depth of 2.5 meters, so by just barely touch the bottom, let's pretend just as he touches the bottom, he's also come to a stop. Okay? What was his average acceleration? I don't know if I can go F equals ma right now because I don't know of force yet. So I think based on what we found in part A and part B, I think I'm going to find the acceleration by using the DFIC kinematics stuff from before Christmas approach. So what do I know? I guess the distance we're traveling is 2.5 meters. Mr. Dueck, are you ending up below from where you started? Could you call that negative? I'm not sure yet, Kenley. I'm going to leave it as positive, and if I get weird answers, I'll go back and stick a negative in front of it. Is that okay? What's VF? At the bottom for a split second if we just barely make it to the bottom? Oh, what's VI? It's not 19.5. Oh, negative 19.5, except I'm going to use my answer button. I'll write negative 19.5, but conveniently I have negative 19.5499. Now, if I needed to, I'd probably, if I wanted to write this out and I knew I was going to use it, I'd go negative 19.55. That's a nice place to round off because it's 499. I'll be still pretty accurate. Okay. A equals which equation? So get the A by itself. VF squared minus VI squared all over 2D. It's going to be 0 squared minus negative 19.5 squared all over 2 times 2.5. Zero squared minus answer button squared divided by 2 times 2.5. What's the negative here? So you get negative 76.44 if you use your answer button? Yes? Should be close if you didn't use your answer button. What's the negative here telling us? Doesn't tell us that we're accelerating down because we're not accelerating down. Which way are we accelerating? We're accelerating up, but we're slowing down. And so, Kenley, it all depended. If you had decided to let down be negative, you'd get a positive acceleration, and that would be telling you that you were accelerating up. Or if, like me, you didn't let down be negative, you get a negative acceleration, and that's telling you you're slowing down, which means you're accelerating up. So we can interpret it two different ways. Okay? So you'll notice as you learn more physics, I'm a bit less fussy in some ways. I'll just say make sure you interpret it correctly. So, sorry, what did we get? Negative 76.4? Logan, it's an acceleration. Good. I haven't turned the page yet. This is just a guess. Is there a part D where they're asking about force? Now, how did I put that together? We haven't used that mass yet, and we've spent some time finding some accelerations. I bet you there's going to be a F equals what? Total guess. Let's find out. Oh, yeah. What's the net force? Now, do me a favor. Everybody right now, all of you, everyone, underline the word net. If I ever say net force, what that means is you don't need to do a free body diagram. I've done a free body diagram for you already. You can go straight to saying F equals MA. Because I have some students, shouldn't I, Mr. Dueck, draw a diagram of the water and gravity down and water pushing up? And no, we've taken care of all that. So, what was the mass? Was it 65? A is, I'm not going to include the negative. I'm just going to want the magnitude right now for the net force. Although, also, I'm not going to type 76.4. What am I going to hit on my calculator? 76.44 or my answer button. Now, if I want to use my answer button, but I don't want the negative, how can I clear a negative and still use my answer button? You ready? Look up. Because what's a negative? Right? There's a negative inside the answer button. I'll do that quite often because if you haven't figured it out, Evan, I'm lazy. I'll look for shortcuts. I don't want to retype this whole thing, but I don't want to carry the negative with me. Oh, just put a negative in front of it and I'll get a minus, which is plus. I get a net force of 4,970 newtons. Is that a lot? I don't know. Well, what was the acceleration? Negative 76.4? That's around 7.5 Gs. You'd feel that. You might even have a bruise. Okay? Are you going to the hospital? Who remembers? We kind of talked about this a couple of days ago when we watched the Mythbusters video. How many Gs do you generally start to break bones around usually? Around 10. So you're probably not going to the hospital. If you hit the landing straight in with your feet, you're okay. If you belly flopped doing this, you might end up going to the hospital because you could have cracked your spine a little bit or twisted your back or done something. We're right on that threshold of between fun and injury. Okay. Example 12. What does FBD stand for? Oh, okay. It says, draw a free body diagram for a cyclist moving to the right at a constant speed while pedaling. There's the cyclist. What are the forces acting on this cyclist? Get the obvious one. Is this cyclist sinking into the ground like quicksand? Is this cyclist flying into air like Superman? So there must be a force pointing up. Bigger, smaller, or the same size as gravity? Same size. What's pushing up? So I know that's there because of Newton's first. I'm going to use Newton's third to figure out what force that is. What force pushes the bike up? What keeps you from sinking? What keeps the biker from sinking? What if they were on water? Would they sink? Yeah. What force pushes the biker up? Huh? Ground. Ready? Forces come in. The bike pushes down on the ground. What does the ground do? Pushes back on the bike. That's why I said I used Newton's first to figure out that the force had to be there. I used Newton's third to figure out, hey, which force is that? What else? Well, you're pedaling. I think, yes. I've ridden bikes. Why can't this be right? What two words should I have underlined in this question as the key phrase? You know what? In our notes, let's underline constant speed. What does constant speed mean? What's 0? Ah, and that's a hugely important situation, because if A is 0, I know the forces must be, I'm looking for a word that begins with letter B. Are these forces balanced? So I know, and you can do this too, there has to be an arrow the same size to the left as there was to the right. Okay? What force is that? Now, I want you to imagine that you're riding your own bike and you're pedaling as fast as you can, but you're not speeding up. What force can you feel on your body slowing you down? This is air resistance. And this is why the Tour de France or the pros tuck in, and because you can, if I can lower air resistance, that means I'll have a slightly bigger pedaling force that's unbalanced, be able to accelerate a bit faster. They've done the physics, okay? So this is going to be, by the way, the fancy word for air resistance is drag. But if you want to call it F with a little air, I'll get exactly what, I'll know what you mean, absolutely. But if you want me to call it something proper, really in this parachuting question back here, oh, I did call it drag. Okay, good, I did use that term. Okay. This would be a nice example of a free body diagram test question. I'd probably make it worth 2 marks. How many arrows did we draw? I'd probably go half mark per arrow. Now, what if instead of moving to the right, what if we were slowing down? That's a good question. Example 13. Draw a free body diagram for an inline skater who is dragging the toe of one skate in order to slow down and stop. What are the forces acting on the skater? Let's get the obvious one. Is this skater sinking into the ground like quicksand? Are they flying through like Superman? So there must be the same size force pointing up. What force is that? Yep. All right. Now we'll see how good you are, because this is a tricky question. What else? Well, are we speeding up or slowing down? Let's assume we're traveling to the right, because that's my default, just so all of our pictures look the same. So if we're traveling to the right and we're slowing down, what direction are we accelerating? Left. Which way must there be an unbalanced force pointing? What force is that? Well, when you're dragging something in a couple of days, you're going to learn a special name for that force. I'm going to give it to you now. When you're dragging something along another surface, we call that friction. Now, if you look at that picture, which way is this object accelerating? Can you give me a word that begins with the letter L? Okay, so and backwards slowing down. So which way is this object accelerating? Okay. Do I need to have an arrow pointing to the right? What force would that be? Let me ask you again. Do I need to have an arrow pointing to the right? There is no force pointing to the right. The most common mistake, students mix up speed with acceleration. I realize the velocity is to the right because you're moving forwards, but are you speeding up or slowing down? That free body diagram there will slow you down quite nicely. There is no arrow pointing to the right. And Rowan, students so want to put one there because, well, you're moving forwards. Yeah, that's because of Newton's first. You want it to keep going in a straight line at a steady speed. Dragging your foot is what changed that to make you slow down. Is that okay? Courtney, that's it. That's the free body diagram. Oh, students, even my Physics 12 students, they often want to put an arrow. I've seen physics teachers wanting to put an arrow pointing to the forwards. No forwards arrow. I already assigned number 1. You can try number 2. I'm going to assign number 3, but put a star next to number 3. Here's what I mean. Number 3 is Physics 12. In Physics 12, if you take Physics 12, you'll find often what I do is I give you a question with no numbers. This is a question with no numbers. Instead of telling you the mass in kilograms, instead of telling you the force in newtons, instead of telling you the acceleration in, Logan, what would the units be for acceleration? I'm giving you something completely algebraic and saying spot the pattern. Now, if you're a math nerd, see my shirt? If you're a math nerd, you'll do it algebraically. But if you want to answer number 3, another way to answer number 3 would be to make up nice numbers. To say, okay, force F, I'll let it be 12 newtons. Why 12? Because lots of numbers go evenly into 12. My go-tos are 12 and 48 because lots of numbers go into 48, and I want to be able to do the math in my head. I'm that lazy. Accelerates at a rate A, I don't know, 2 meters per second squared, 4 meters per second squared, 5 meters per second squared. And then you can actually calculate what the rest of the numbers have to be and spot the pattern. The only thing is, if you're making up numbers, never make up the number 1, because the 1 times table behaves differently from all the other ones, and you might spot a pattern that isn't really there. Okay? So try it. See if you can figure it out. 4 is good. 5 is good. 6 is good. 7 is good. 9. 9 is tricky. It's all Physics 11, but it's multiple steps. In fact, I changed the numbers and I reassigned this in Physics 12, and I still have kids ask me questions. So this one I would say is fair game, but it's tricky. Number 3 is not really fair game for you folks, but okay. Number 10. Number 11. So far I skipped 8, right? I'm trying to give you lots of time to work on this as well. 12 is good. 13 is good. 14 is good. If you write small, you might be able to do these on the same piece of paper. It's up to you, Rowan, whatever you feel helps you learn better. If you want to do these nicely on a separate piece of paper, you can. Or if you want to do the ones where I gave you a diagram on the homework paper, you can, and just staple the ones where you couldn't fit it in on a separate piece of paper, go ahead. Whatever works better for you. Okay? We talked about, we saw the video Why the Earth Spins last class, yes?